Today's notes are on lines and line segments. We're going to start by reviewing the defined term of a segment. And a segment is part of a line that consists of two endpoints and all points in between. So while I gave you this example here, let's all take a moment and look at another example. Okay, let's label this with the script M so I can call it line M. Here I have line M. Line M extends in both directions, so therefore I know it is a line. It continues forever on both sides. But it's also made up of a bunch of points. And I labeled 4 points. However, there are more points than this. A line is made up of infinitely many points. But on the points, or within the points that I labeled, we can clearly look at a few defined segments. So I could say that between W and X is a line segment. I could say between Y and Z is a line segment. I could say between W and Z is a line segment. We could do a segment between X and Z, or a segment between WY, and this list could keep going. So line segments are two segments formed between any 2 points. I said two segments, sorry. One segment formed between any 2 points. If we look at the example that I drew for you, here we have segment AB. You name the segment by its 2 endpoints. You use a segment bar above the endpoint. So this is segment AB. I label it AB with this symbol above. It doesn't matter the order, so I could also label it BA, however you want to. If we look at our first example set, has a diagram over here to the right. And number 1 says to name all segments. So I'm going to look at this, and of course there's different ways to label each segment. For example, I could be labeling segment AB as AB or BA. I'm just going to label it in alphabetical order. So let's start with labeling the first one as segment AB. I'm going to go through and I'm going to do all of my small individual segments. So AB, next I'm going to label BC. Also could be CB if you want to. Then I have CD. After I label my 3 individual segments, I'm going to continue by looking at larger segments, so maybe segments that include 3 points. Of course, you still name them with 2, but containing 3 points, I have a segment between A, B, and C. We will only label that as AC. You only label with your 2 endpoints. For the next segment that involves 3 points, we could have points B, C, and D falling within a line segment. Of course, we would label that as just BD. And I think there's only one more here, and it's the segment between A and D, so it's this entire segment. Can't do anything more than that because we don't have any more labeled points. What we could do is we could reverse the order of these points. Within this line L, we have 6 line segments. Number 2 in this example asks us to label the line in 3 different ways. So line is what we learned about yesterday. And you can label a line by its endpoints or by the lowercase script letter, which would be this letter here. So I'm going to start with that letter, and I'm going to label this line as line L. That's my first way of labeling this line. I also can pick any 2 points on the line and I can label my line that way. So I'm going to pick points A and C. And let's label the line as AC. Make sure you use the correct notation above. AC with a line bar with arrows on each side above the letters or above the endpoints. Next, I'm going to use the points. Let's use B and D. You can label a line with any 2 points that are on the line, and you make sure you use the correct notation. So this list would continue. These are not the only 3 ways to label it. There's probably 10 different ways to label this line. We just listed 3 of them. We just went over line segments. Line segments are a really big topic in geometry. We use them throughout the entire year. But there are some other important parts about lines that we need to know. The first one being parallel lines. Hopefully everyone has heard of parallel lines before. It is a topic that you should have looked at earlier in math classes. Parallel lines are coplanar lines that, and if you can fill in this blank by yourself, that's awesome. The solution would be that do not intersect. And they don't intersect, they never intersect. So I'm just going to put in parentheses, never. Focusing on notation, because we will be using it. If you have parallel lines, you usually indicate that the parallel lines are parallel by drawing a little arrow on each line. So that arrow matches on each line and indicates that the 2 of them are parallel. And when you write out parallel lines, in this case, we would say line A. Parallel symbol is 2 straight bars. So line A is parallel with line B. Next, we're looking at perpendicular lines. Also something you've probably seen before. We use it a lot in geometry. Perpendicular lines are lines that intersect at a right angle. And in this example, these 2 lines intersect right here and they form a right angle. If we were to use notation, we would label this as line M is perpendicular, and it looks like an upside down T. That's the symbol. Line M is perpendicular to line N. And skew lines. So skew lines are non-coplanar lines that do not intersect. If you are thinking about skew lines in the real world, think about a line on the floor of the room that you're on and a line on the ceiling of the room that you're in. I said on, but in, yeah. So think of a line on the floor, think of a line on the ceiling, and imagine that they never touch. I mean, they couldn't touch. One of them is on the ceiling, one of them is on the floor. They will never touch if they continue on that surface. Those are considered skew lines. Moving on to more examples. We have a couple of drawings here. So number 1, we're going to answer parts A and B for number 1. Part A asks us to name a line. So there's actually only one line in this figure. If I'm looking at this model, I have this here, and the only way I know that's a line is because I see that both ends extend forever. If those ends do not extend forever, then it is not considered a line. For example, right here, this is not a line because only one end extends. So our only line, our only answer for part A would be line KL or LK. And for two line segments, I have a segment here between K and L, and I also have a segment here between J and K. KL, or you could write it LK, and JK, or KJ. For number 2, I'm going to use this pyramid that you see. Part A says to name a plane that contains point X. Here's point X, and it looks like it's contained within 3 planes. The first plane being the base. The base has a corner labeled X. The second plane being this side here, with the bottom right corner being X. And the third plane is this plane in the back, with the bottom right corner being X. So pick any one of those 3 planes and label it. I'm going to pick the one I currently have highlighted, and I'm going to label it as plane XYZ. Part B, we're asked to name 2 lines. So what you see here is just a line segment. So we see 2 endpoints, for example, W and X, and we see a segment in between them. But recall from our definition earlier on this page, a segment is part of a line. So even though you don't see this line does extend in both directions forever. The segment is just a small portion of it. So I'm going to label that line that I just marked, and that's going to be labeled as line WX. And we could have a line between Z and V. Of course, between those 2 lines is a segment, but the segment is part of a line that extends forever. So I am going to label this ZV. And you could continue naming multiple other lines. Part C says to name 2 parallel line segments. Looking at this model, the only segments that could potentially be parallel would be segments that fall on the base of this figure. So maybe segment V or YV and XW, those 2 segments will never touch. Imagine if it's the base of a pyramid. 2 opposite sides will never touch each other. They are parallel lines. So we could label our parallel line segments with the correct notation as VY with a segment bar, our parallel symbol that we talked about, and then WX with a segment bar, because you're dealing with line segments. D says to name the intersection of plane YWZ and ZYV. So the first plane, VWZ, is this here. And the second plane, ZYV, is this plane on the side. So it looks like these 2 planes intersect at this line, which would be line VY. And it is a line because it does extend forever. I know you only see a segment, but there is a line there. Okay, please take a moment and complete the on your own section by yourself. Press pause on your video and then come back to check your answers. Next, we're looking at congruent segments. And congruent segments are extremely important for the entire school year. So congruent segments are segments that are equal in length. Congruent line segments are usually indicated by drawing the same amount of, in quotes, slashes in the middle of the line segment. And this is what I'm referring to here. So because both line segment AB and line segment CD have two little slashes on them, that indicates that these segments are congruent. And the congruent symbol is an equal sign with looks like a squiggly above it. This here. So in order to write that segment AB is congruent to segment CD, we write it like this. And all of the notation in this sentence, I know it's a math sentence, but in this sentence is crucial. You have to understand that your segment bar looks like that. You have to understand that your congruent symbol is used here. And again, you have a segment bar. So make sure you indicate using the correct symbols. I'm going to start by identifying and highlighting. I'll use a blue highlighter. I'm going to highlight everything that has one congruent slash. And I'm highlighting these just so I can clearly see where they all are. Okay, so I just labeled all of the congruent symbols with one slash. And now I'm going to go back through and I'm going to highlight all of these as segments. So segment A to B is congruent with segment B to C, which is congruent to segment C to D, and then D to E. I'm also looking at a congruent segment here from G to D, from G to C, and from G to B. So I have a lot of congruent symbols that have that one single slash mark. I'm going to write out this statement with a blue marker because we have other statements that we need to write. So starting over here, we have segment AB is congruent to segment BC, which is also congruent to segment CD, and DE, oops, and then we had segment GD, we had segment GC, and lastly we had GB. So we have a lot of congruent segments here. All of these would be equal to each other. So if we had an actual length there, say they were all 6 feet, every portion of this figure would be 6 feet. That has that one slash mark. Next, highlighting in, let's do purple, I'm going to highlight anything with 2 slash marks. We have a segment here, 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 and here. That means we have segment AH, segment HG, segment GF, and segment FE as all congruent segments. Labeling them, we would have a statement like this. And lastly, we have two sections that have three congruent bars, here and here. So I can say that segment BH is congruent to segment DF. The segment addition postulate. So this postulate says that if you have 3 points, A, B, and C, that are collinear, and B is between A and C, then you can say that segment AB plus BC is equal to AC. So I think this is pretty obvious when you look at it. If you say segment AB plus BC, that would be this here plus this here is equal to the entire length. So of course that would be true. I think everyone can figure that out, but it is called a postulate and you do have to make sure you use the correct notation. So we always write this as AB plus BC is equal to AC. We do not write it as segments. We don't write AB with a segment bar plus BC with a segment bar is equal to AC with a segment bar. This is wrong. You only use that segment bar when you're naming from a diagram. So moving right into the examples, these examples involve algebra, which is nice, brings back a little bit from last year. Number 1 says if dt is equal to 60, find the value of x. Then find the value of ds and st. So dt is equal to 60. That's telling us that the length of the line, or the entire segment, is equal to 60. So if we add up each individual segment, or each of the parts, we know the total length is 60. That means if we add ds plus st, it's equal to dt. All right, I know ds is represented with the expression of 2x minus 8. So I'm going to replace dx with 2x minus 8. I know st is represented with the expression of 3x minus 12. And I know that dt is equal to 60. That was given in the statement above. At this point, it becomes a simplifying expression, and you need to solve for x. So in order to do that, I'm going to combine my like terms. I have 5x minus 20 is equal to 60. I'm going to add 20 to both sides. 5x is equal to 80. Divide both sides by 5. X is equal to 16. So that answers the first part of the directions. The directions say to find the value of x, but then also to find the value of ds and st. So we just found our value of x. And now let's substitute that back into my expressions. So let's start with ds. So ds is equal to 2x minus 8. We're substituting the value of x, which is 16, back into this expression. So we end up with 2 times 16 minus 8. That would be 32 minus 8, telling us that segment DS is equal to 24. The next segment is segment ST, and ST is equal to 3x minus 12 in our diagram. If we substitute 16 in for x, we have 3 times 16 minus 12. And 3 times 16 minus 12 is 36. That's 48 minus 12. That means ST is the length of 36. And that's your answer for number 1. So you solve for x, and then you substitute back in, and you solve for each segment. Let's look at number 2 a little bit faster. So I'm not going to write out all the steps here. We can skip through a little bit just to make sure we get this problem done a little quicker than the last. Our description tells us that EG is equal to 100. Our directions tell us to find the value of x, then find the value of E, F, and FG. So we are looking for these two segments. I know that if I add EF plus FG, it equals the total length of EG. I know that I can replace EF with the expression of 4x minus 20, and I can replace FG with the expression of 2x plus 30, and this is equal to 100. When we combine like terms, we have 4x plus 2x is equal to 6x. Negative 20 plus 30 is equal to 10. This is equal to 100. Subtract 10. 6x equals 90. Divide by 6. X is equal to 15. Now we're going to substitute this back into our originals. We know that EF is equal to 4x minus 20. When I substitute 15 in, we have 4 times 15, which is 60, minus 20. That would be 40. So EF is the length of 40. And then we have segment FG. FG is equal to 2x plus 30. Substitute 15 in for x. Once you do that, you have 2 times 15 plus 30, which is 60. FG is equal to 60. And for the last section, we're looking at midpoints. So midpoints of a segment is a point that divides a segment into two congruent segments. Looking at this model here, Y is the midpoint. It's specifically the midpoint of segment XZ. So by having a midpoint, you're now creating two congruent sections. So I could say that segment XY, that would be this segment here, is congruent to this segment because the midpoint creates two equal segments every time. You don't have to see these symbols. If you see a midpoint, if something is identified as a midpoint, The rest of this is automatically assumed. Example 1 says that C is the midpoint of AB. So if C is a midpoint, we instantly know that segment AC is congruent to segment CB. That's what that is telling us. So I'm going to go ahead and set up my formula. I know that AC is congruent to CB because of the midpoint. If I know they're congruent, then I know that they are equal. So check your notation here. Knowing that they are equal, I can set up an equation that says 2x plus 1 is equal to 3x minus 4. And then you just solve for x. So solving for x, I'm going to subtract 2x from both sides. 1 equals x minus 4. Add 4 to both sides, and x is equal to 5. Because x is equal to 5, I can now find the length of each segment, which, by the way, each segment is equal, so when you check this number, you should get the exact same value for each segment. We know that AC is represented with 2x plus 1. If I substitute 5 into this equation, I have 2 times 5 plus 1. AC is equal to 11. And I'm just going to double check my work here, so I am actually going to solve for segment CB. CB is equal to 3x minus 4. Substitute 5 in for x, you have 3 times 5 minus 4. 3 times 5 is 15, minus 4 is 11. So CB is equal to 11. Okay. By checking both of those, I know that my answer is correct because they came out to be equal. And that's what the midpoint is telling us. So it's telling us that it has to be equal. And for the last part, we have to find AB. So AB is the total line, or the total segment. It's the equivalent of adding AC plus CB. That's the equivalent of adding 11 plus 11. So therefore, AB is equal to 22. Okay, I'm sure you can do a lot of this in your head, and that's okay. You definitely can do most of these steps in your head. Just make sure when you're showing your work, you show enough steps for me to know what you're doing. So don't leave off anything crucial. You can do those basic math steps in your head, and then you should write everything else down. For the last part, please pause your video. Please complete this on your own problem by yourself, and then check back to the video to see if your answer is correct.